Good morning, students. Good morning. How was the test? Hmm? How was the test? How you people have performed? Hmm? How much marks you are expecting? With regard to the test I am talking about, how much marks you can expect? Yes, good morning to everyone. So all of you have performed very nicely. Whatever test has been conducted on Saturday. Hmm? Yes, sir. Okay, now Manjunath gave the answer. What about others? So all of you have performed nicely. Okay, Likita. Yes. Okay. Yes, Pooja. Done. So in that case, very good. Fine. So no need to worry. If few questions if you have not understood, no need to worry. We have not got our marks. It will be given. It will be given. Don't worry, it will be given. So yes, Rakesh, that's what I told. So marks I don't want based on your performance. What you feel. Okay? So start preparing now itself. Whatever COVID this one is happening, so don't worry about all those things. Try to focus on your studies. Okay na? So today what I will do is another 2-3 questions related to structure of atoms we will solve it off. Then I will move to new chapter. Okay? Sir, you can solve 12th question. Okay. What was that 12th question? 1 minute. Okay. You are talking about which of the following sets of quantum number represents the highest energy level in an atom. That's what you are talking about, Manjunath. Oh, maybe. Or you are talking about out of the following which is the correct set of quantum number for outermost electron, which you are talking about. Oh, test question paper I don't have with me, pa. I don't have that test question paper. Anyway, you send me through WhatsApp. I will solve it and I will send you. I will give you the answer. I'll put it in the group. I don't have test question paper at present with me. Okay? Fine. So don't worry. We will solve it. Last class, 11th questions are done. Yes, Sappa. No, I got confused. So 12th question I thought he is talking about CET NEET questions. Manjunath, don't worry. So you send me that one through WhatsApp and we will solve it off. Okay? Or tomorrow in the classroom itself we will solve it off. Anything is fine. But you can send me through WhatsApp or I will go through that. Once I reach home, I will go through that. Okay, which is that question? So 12th question. Okay, fine. So then in that case, we will move to the next one. Okay, so that is 12th question. If the kinetic energy, if the kinetic energy the kinetic energy of an electron is increases 4 times, the wavelength of the de Broglie's wave function, wavelength of the de Broglie's wave associated with it would be associated with it would be A 2 times, B half, C 1/4, and D 4 times. It's a JE question. Okay, so it's a JE question. Yes, Sanjay. Hello. Okay. So if the kinetic energy of an electron is increases 4 times, the wavelength of the de Broglie's wave associated with it would be option A 2 times, option B half, option C 1/4, option D 4 times. Okay. Now this is related to JEE. So that's what I was telling. When it comes to need and JEE, there will be few questions once in a while they will ask. So which will not be found in your NCERT textbook. Few concept, very few concept. Okay. But in this regard, you might have studied this one in your physics, or you will be studying this one in your physics of one particular concept. Okay. So now naturally this is based on de Broglie's equation. Okay. So this is based on de Broglie's equation. So now what is that they are telling? De Broglie's wave associated with, they are asking, right? Now all of us we know that lambda is equal to h/p, right, according to de Broglie's equation. Yes, Prithvi and Dikshit. Okay, good morning. So when I am talking about de Broglie's equation, wavelength is equal to h/p. So what do you mean by h? Planck's constant. So what do you mean by p? Momentum, right? So that's where we have the equation. Okay. Yes, Dikshit, 3 times. Okay. So that's where we have the de Broglie's equation. So lambda is equal to h/p. So p is nothing but momentum. So therefore if I rearrange this, p is equal to h/lambda. P is equal to h/lambda. Okay. So now momentum and wavelength, they are inversely related. Yes, Vishwas, P means momentum. So momentum and wavelength, they are inversely related to each other. Okay. Now we have one particular equation, that's what I wanted to tell, which you have not studied in your chemistry. So kinetic energy is equal to P square divided by 2m. Okay. So P square means this is related to momentum, m is related to mass. So what is kinetic energy? Kinetic energy is equal to half mv square, right? So that's where P square divided by 2m, which you might be studying in your physics. So that's where we have the one particular equation. Okay, fine. Some of you have given the answer half, 1/4 time. So we will see. Okay. So which one will be correct? So what I meant to tell you is this is where we have the equation. Now substitute the value of P in this. So kinetic energy is equal to h square divided by lambda square, because we have P square, divided by 2m. So that is nothing but h square divided by m lambda square, right? So that's where I have the equation. Now for a particular object, mass will be constant. And h is a Planck's constant. So therefore I can mention that lambda is proportional to 1 by square root of kinetic energy. Square root of kinetic energy, because so lambda I am taking here, kinetic energy I am taking here. Since lambda square it is there, so therefore lambda will be equal to 1 by square root of kinetic energy. All of you have understood? Okay. Since the square root of kinetic energy is there, since that will be increased in 4 times, naturally half of that one should be wave related to waves. Half of that one should be related to waves. All of you have understood? So if wavelength is proportional to 1 by square root of kinetic energy, so that means kinetic energy to the power of half is there, 1 by 2. So therefore when 4 times increase will be there, it should be half, wave should be half of that. Okay. So anyway, so we can mention with this one, half. We can mention with B, not 2. We can mention with B. So de Broglie's wave associated with would be half of the kinetic energy, whatever we have. Okay, half of the kinetic energy, whatever we have. So therefore, we will go with B. Okay, all of you have understood? So that's where if the kinetic energy of an electron is increases 4 times, the wavelength of the de Broglie's wave associated with would be half of that one, or whatever that value is there, half of that one should be wave. That's what option B indicates. All of you have understood? Anyway, you have got this equation in your chemistry textbook is there, but only thing is this is the one new equation we have got it, and definitely if I am correct, you people are going to study this one in your physics. Okay, so therefore when you want to score high in your JEE and NEET, so what you have to do is you have to bit focus on competitive exam textbooks. And even I think you might have supplied with competitive exam books from learners also. Anyway, so those things we have to solve more. And try to read whatever introductory part will be there. Okay, concept explanation. So in that, some of the equations will be there. Try to practice those equations. Okay. Any doubts? Shall we move to the next one then? Okay. So we will move to the next one. That is 14th question. Once again from JEE, 14th question. Which one among the following? Which one among the following statement is correct? Which one among the following statement is correct? Okay. Now, option A, an orbit containing an electron having quantum numbers s is equal to n is equal to 2, L is equal to 0, ML is equal to 0, and S is equal to plus half is spherical. That is one thing. Option B, wave number of X-rays. Okay, it's not wave number, it should be frequency. Wave number, it should be frequency. So frequency of X-rays is less than radio waves. Option C. all photons have same energy. All photons have same energy. And option C, as intensity of light increases, as intensity of light increases, frequency also increases. So this is what we have the options. Which one of the following statement is correct? Option A. An orbit containing an electron having quantum numbers n is equal to 2, L is equal to 0, ML is equal to 0 and S is equal to half is spherical. Option B. Frequency of X-rays is less than radio waves. Option C. All photons have same energy. And option D. As intensity of light increases, frequency will also increase. Okay? Okay, it should be, I have written wrong here, that's what the mistake. It should be 13th. Yeah, it should be 13th. Yes. I think I have written here it wrong. It should be 13th. Anyone? Which one is wrong they are asking? 13th questions. Yes, Vishwas. I have written here wrong. From yesterday, means last class only, I have skipped one question in between with respect to number. That's why I am making a mistake. So Manjunath, according to Manjunath, it should be option D. As intensity of light increases, frequency also increases. That question is, which of the following statement is correct? Rakesh, option B. Frequency of X-rays is less than radio waves. Okay. All of you are going with option B. Okay, they are asking which is the correct statement, and according to you it should be option B. Except Manjunath. All of you will agree? All of you will go with option B then? Okay, Shashank is there. Absolutely correct answer. It should be option A is the one which is correct statement. Option A is the one which is correct statement. Yes, Rohan. Rest of the questions they are wrong statement. X-rays, highly energetic. Radio waves are least energetic. Therefore, although we are listening to radio, FM radio and all, no need to worry, we will not be prone for the cancer. But when you are exposed to the X-rays very often, 100% you will be prone for one or the other disease. So that shows X-rays are more energetic compared to radio waves. So naturally this statement is wrong. All photons have same energy. Wrong statement. That depends. So intensity of light increases, frequency also increases. That is also wrong statement. For intensity and frequency, they are not directly related. They are not dependent on each other. So that's where only option A is the one which is the correct statement. Because when I am telling L is equal to 0, that means I am dealing with S subshell. I am dealing with the S subshell, and naturally S subshell orbital will have spherical shape only. They will be having spherical shape only. Therefore, only option A will be the correct answer. All of you have understood? Rest of the options, they are wrong statements. Dikshit, option B is actually wrong. So X-rays, they are having high frequency, very very high frequency. Therefore, X-rays are much more energetic compared to radio waves. Since frequency of X-rays are very high, so therefore X-rays are having very high energy compared to radio waves. We cannot compare energy of radio waves with the energy of X-rays. They are not at all comparable. So one is having least energy and another one is having very high energy. So naturally frequency and energy, they are directly related. So X-ray should have very high frequency. Okay, fine. We'll solve another question. That is question number 14. The ratio of radii of first orbits of hydrogen, helium plus lithium plus 2 is. This is also JEE, but I think I have seen somewhere else also. Okay. So 1 is to 2 is to 3. Option B. 6 is to 3 is to 2. Option C. 1 is to 4 is to 9. And option D. 9 is to 4 is to 1. So these are the options. The ratio of radii of first orbits of hydrogen, helium plus and lithium plus 2 is. That means they are talking about hydrogen like species. Okay. So Maurya is already given the answer, option A. We will see. So option A is 1 is to 2 is to 3. Option B is 6 is to 3 is to 2. Option C is 1 is to 4 is to 9. And option D is 9 is to 4 is to 1. Okay. Fine. Anyone of you have started solving this one? Okay, even Pooja, she is telling option A. We will see. So they are dealing with hydrogen-like species. Hydrogen and hydrogen-like species. Okay, option B. Okay, Rakesh, we will see. Very good. So that should be the answer. I will tell why. Rn or R is equal to, what is that equation we have? N square divided by Z into A naught. That is Bohr's orbit. That is 0.53 angstrom or 529 angstrom. If you are more specific, it can be written as 0.529. Since 9 is there, I have taken it as round off, 53. Okay. Now in that case, for hydrogen it will be 1 square divided by 1, because atomic number for hydrogen is 1, multiplied by 0.53 angstrom. Okay. All of you have understood? So then we have helium. So this is for hydrogen. So this is for helium. So once again, 1 square divided by atomic number for helium is 2, multiplied by 0.53 angstrom. And for lithium plus 2, it will be once again 1 square divided by 3, because atomic number for lithium is 3. 0.53 angstrom is constant. 0.53 angstrom is constant. Don't worry about that one. For everything it is constant. Variation is with respect to here, atomic number. The difference is with respect to atomic number. So therefore, listen to me carefully. We should not give the option A and option C. It's absolutely wrong. Because as the atomic number increases, radius is going to decrease. Yes, Rohan, this will be last but one. We will go with next chapter. Okay. So n square divided by Z. So Z is 1. So for, please remember, radius is inversely proportional to atomic number. So therefore, please remember, you should not go with option A and B, because it shows that hydrogen is having lesser radius compared to helium plus and lithium plus 2, which cannot be possible. Now either it should be option B or option D. Naturally, 1 by 1, that is 1 only, then half, then 1 by 3. So we can go with option B. Right? So we can go with option B. So we are not going to consider this one. Half and 1 by 3. So that's where I can go with option B. 6:3:2. All of you have understood? Straight away we can remove option A and option C from our list. Okay na? So yes, Vishwas. Next will be the last one. Okay? Next will be the last one. Don't worry. Next will be the last question. We will finish it off. When I can understand, we will finish it off. Next will be the last question related to objective type questions. And we will continue with the new chapter. Yes, I can understand. Because it's more than a week. Today we are coming with new week. So I thought another 2-3 problems I will solve it off. Okay? So last question, don't worry. Okay. So 15th one. The wave number of first emission line in Balmer series, in the Balmer series of hydrogen spectrum is option A 3R divided by 4, option B 9R divided by 400, option C 5R divided by 36, and option D 7R divided by 6. Okay, so these are the options. This will be the last one. Okay na? So the wave number of first emission line in the Balmer series of hydrogen spectrum is, now focus here, this will be the last question. So option A 3R divided by 4, option B 9R divided by 400, and option C 5R divided by 36, and option D 7R divided by 6. Solve it fast. Last one. This will be last one. Fast. All of you have started solving this one. Okay, Rakesh is telling option C, 5R by 36. All of you will agree? 5R by 36. Yes. So that should be the answer. Option C should be the answer because they are asking about wave number, right? So wave number and frequency, they are directly proportional to each other. Wave number and frequency, they are directly proportional to each other. Or, so Ni will be 2 square minus Nf will be 3 square. If you remember, for Balmer series, N1 or Ni is equal to 2 and Nf can be 3, 4, anything. Okay, if you remember, for Balmer series. And they are asking about first emission line. That means immediately next energy level we should talk about. Because for Balmer series, Ni will be equal to 2. It cannot be 1. and final energy level will be 3, 4, it can be anything. Since we are dealing with first emission line, we have to talk about 3. Okay? So in that case, further if you solve R 1 by 4 minus 1 by 9, so I take common denominator as 36. So therefore, here it will be 9 minus 4. So that is nothing but 5 by 36 into R. 5 by 36 into R. All of you have understood? So that's where we have the answer for this particular question. Any doubts? Have kept aside. Any doubt? Option C will be the answer. Any doubts? Okay, why we have considered 2 and 3? For bomber, Ni can be 2 and Nf can be any of these energy level, but it should not be 2. So it should be more than 2. It can be 3, 4. Okay? Since they are asking about first emission spectra, so that's why we have taken Nf value as 3. Anyway, I will stop here because already people are complaining that, sir, we got bored. Yes, definitely. We will start with the new chapter. Okay, we will start with the new chapter, but this one is practice more questions. Okay, so try to practice more questions. So we are going with new topic, that is called as periodic classification of elements. Periodic classification of elements. Okay, all of you have understood? Now, this is with respect to a new chapter. Try to understand this one also. Very important for chemistry students. Now, when I am telling periodic, whenever we were in high school or we were in school, now we are in college. Anyway, in college regular class has not been started. It's online class happening. But here also we have the timetable. We have the timetable and we will call it as period. In that timetable we will call it as first period is maths, second period is chemistry, like that we will be discussing. What I mean to tell here is periodic classification means there is something related to regular arrangement. After each interval there is a regular arrangement we can observe. So therefore they are called as periodic. So periodic means at regular interval there is a common thing which we can observe. So that's why it is called as periodic classification of elements. Okay? So at present we have approximately 118 elements. At present we have approximately 118 elements, which we know these are the elements or which have been discovered. Okay, so now among these 118 elements, among these, yes Rohan, among these 118 elements, 94 elements, they are natural. They are naturally present. Okay, and rest of the 24 elements, they are man-made. They are man-made. Okay, so that's where we have 118 elements altogether. Okay, so among these 118 elements, approximately 94 are naturally present. But rest of the 24, that might be during nuclear reactions. Rest of the 24, it is man-made. All of you have understood? They are synthetic. They are not naturally present. They are derived from these elements during some process. So that's where we have the 24 elements which are man-made. Now the question here is, why we have to classify the elements? What is the reason why we have to classify the elements? So that will be the quite common question. So to answer that, we have common example I used to give always. Now if you come to Mysore or whoever already in Mysore, you can see we have different areas. Vijayanagar, earlier Vijayanagar was there, now it has become Vijayanagar first stage, second stage, third stage, fourth stage. Same way we have different locality like Gokulam, right? So why the particular city has to be divided into different area? What is the requirement? Why not the whole Mysore? We will stay together, unity. Okay? So no need of anything. No Vijayanagar, no other, nothing. The whole thing is Mysore. Then it will make havoc because the population of Mysore is high. It is nearly around 12 to 13 lakhs. Right? Now, if you want to communicate with a person, okay, it can be by letter or something, then it will be very difficult if you make it as Mysore. Say for example, I want to tell someone that where Learners PU College is located. Now if I tell it is located in Mysore, then the people will get irritated. In Mysore where? No, it is in Mysore. Okay, so we can't tell like that. We have to specify in Mysore where exactly it is located. To make that one, we will be requiring different locality. Same way, when I have 118 elements and still it will be going on. Okay, so when I am talking about these 118 elements, among these elements, some might be having similar properties. I am not telling same. They might be having similar properties, right? So I want to see for example, now we know what are halogens and examples for halogens, right? So if I talk about halogens means salt producers or salt farmers. That's why they are called as halogens. The meaning of halogen is they are very good salt farmers. Say for example NaCl, right? So same way we have the KCl or KBr. So like that we have different salt. So that's what they are called as halogens. Now all of us we know when I am talking about halogens, so that's where we have the halogens. Example, last astatine we are not going to consider much because they are radioactive. Okay, so we always focus on these four: fluorine, chlorine, bromine and iodine. Now if someone asks you what are halogens, whether they are electropositive or electronegative elements, and which are those elements which are having similar character, now we can easily tell. Yes, halogens are, these are the one. They belongs to group 70. They belongs to group 70. So that's what we can tell confidently. And if you observe, whatever elements are there, fluorine, chlorine, bromine, iodine, all of them, they have the similar outer electronic configuration. So what I mean to tell you is, all of them in the outermost electronic configuration, if I take, they have this type of electronic configuration only. Got my point? Yes, electronegative element, they will have negative charge or they will go with anionic condition. That's where all of them, they comes with outer electronic configuration as outer electronic configuration as NH2, NP5. N is variable depending on which period they belongs to. Anyway, we are going in detail. So what I wanted to tell here is, due to this reason, to easily locate the element which are having similar character, so therefore we require classification of elements, because the number of elements are increasing year by year. It's getting increasing. Some of the old NCERT textbook, if you observe, in that they might have given 114 elements. If you go with much older one, they might have given 110 elements. So that means as the new print is coming, number of elements are also getting increased. Right? So therefore classification is very much required. All of you have understood? Any doubts? Now, it began with the work of Doberener. It began classification of elements. It started with the work of Doberener, who tried first to arrange the elements, and he tried to make those elements which are having common features. Dikshit, at present we have 118 elements approximately. Okay, now? So, Doberener is the one at around 1800. Can you imagine? So old story. But we have to be very grateful to them, because they were the one who gave foundation for the classification of elements. So Doberener is the one who proposed law of triads. Okay? Now, triads means in ಕನ್ನಡದಲ್ಲಿ ಹೇಳಬೇಕು ಅಂದರೆ ತ್ರಿಮೂರ್ತಿಗಳು. Right? Triads means ತ್ರಿಮೂರ್ತಿಗಳು, or it is related to three. So that's where we have the law of triads. Okay? Now, according to this particular law, which is proposed by all the halogens gain a single electron to fill their valence energy level. Absolutely correct, Pooja. And anyway, we are going to discuss all those things in detail. Okay? So that's where we have the law of triads. So what it tells here is, say for example, I have lithium, sodium, then potassium. I have the lithium, sodium and potassium. If you see their atomic mass, it is somewhere around 27, 23 and 39. If you see that atomic mass 7, 23, 39. Okay? Yes, Rohan. Okay, but still it has to be characterized. Okay? Yes. Okay, still it has to be done. That's what I mean to tell. It will go on, it will go on. So therefore classification is very much required. Okay, na? So when I am talking about lithium, sodium, potassium, we have atomic weight as 7, 23, 39. That means law of triad is related to atomic weights of the element. It is related to atomic weights of the element. So what you can observe with respect to atomic weight of sodium with others too, if you compare, what you can observe with respect to atomic weight of sodium? Right? So what we can see here is atomic weight of sodium, atomic weight of sodium is equal to atomic weight of lithium plus atomic weight of potassium divided by 2. That means 7 plus 39 divided by 2, which will be 23. Which will be 23. That's what we can observe, right? It is the sum of the first element and last element is average to the middle element. Yes. So that's what we can observe. So if I see the atomic weight of sodium, if I take the average of lithium and potassium, it will become the atomic weight of the sodium. So, or in another way I can tell that these three elements, like that law of triads will explain. Three elements which are arranged, three elements which are arranged, three elements arranged with respect to increase in atomic weight or atomic mass, increase in atomic weights, middle element will have average of the first and third element atomic weight. Third element's atomic weight. That way you can explain. Or middle element have half of the atomic weight of the last element. Halfway between the first and the last element. That way also we can tell. Halfway between the first and the last element, or you can tell like this. So that's what law of triad is talking about. So board is not clear. Okay. Now it is clear? All of you can see? This one I will explain. Next I will increase the font size. 3 element arranged with respect to increase in atomic weights. Middle element will have average of the first and third elements atomic weight. All of you have understood? So that's what law of triads talks about. Anyway, Ullas, don't worry. I will increase the font size next time. Next time in the sense, whatever next concept I will be explaining. All of you have understood? So that's where we have the law of triads which will be talking about. Any doubt in this? So it is proposed by Doberiner. It is proposed by Doberiner. Okay? So now, he was able to arrange with few elements only, like this, 3 elements. But it will not be reproducible with most of the elements, because atomic weights will not be like atomic number. Okay? So it will vary. It will not be having continuous difference with respect to previous element. So there will be variation will be there. So that's where Doberiner law of triads is applicable only for few elements. It's not reproducible with many elements. Okay? So therefore, at around 1860, somewhere around 1860s, because in 1800 in the beginning, Doberiner's law of triads came. So due to some drawbacks in his law of triads, now came for 1860s where new lands theory came. New lands theory. So new lands law of octaves. Newland's law of octaves. Okay? So Newland's law of octaves came. So law of triads was by Doberiner. Now comes the law of octaves. In the name itself it is there. When I am telling octaves, what do you mean by octaves? Somewhere it is related to 8. Somewhere it is related to 8. That's why we can call it as law of octaves. Right? Yes, all of you are correct. So sir, why should we divide only and lithium and potassium? Why not sodium? Because that's what law of triads. It tells that middle element, when you arrange 3 elements in increasing order of their atomic weight, middle elements will be having average of the first and the third element. So therefore we are considering lithium and potassium. Middle element is sodium. That's why. That is the reason. Okay? So Dikshit, whether I have reached you? Okay? So that's where we have. He used music notes to classify the elements. Okay, in that much detail we will not go. So that's where Newland's law of octaves will come. Hagadre, if I arrange the elements, that is we have lithium, then comes the beryllium, then comes the boron, then comes the carbon, then comes the nitrogen, then oxygen, then fluorine. So then once again sodium, magnesium, aluminium, silicon. So here phosphorus, here sulfur, then chlorine, then once again here potassium, then calcium. He was able to arrange up to calcium. Okay? So that's where we have the law of octaves which is applicable up to calcium. Yagnesh, no inert gas. Okay, so that's what he arranged. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, calcium. Only up to here he was able to arrange. Okay. ಹಾಗಾದರೆ if you see law of octaves, why it will be called as law of octaves? Now you are going to understand. If I start with lithium, so then I can tell 1, 2, 3, 4, 5, 6, 7, 8. Lithium and sodium, they are having similar properties. So first and eighth element, they are having similar properties. Even now, in modern periodic table also they comes under same family, same group. Okay. Now, if I consider beryllium, 1, 2, 3, 4, 5, 6, 7, 8. That means first and eighth element. Even now, they are present in the same group. Alkaline earth metals, alkali metals. Right? If I come with boron, that is 1, 2, 3, 4, 5, 6, 7, 8. Boron and aluminium. Okay? They are having similar property. Even now, they are present in group 13, 1, 3. Right? Now, if I go with carbon, 1, 2, 3, 4, 5, 6, 7, 8. Carbon and silicon, even now they are present in the same group. Group 14, 1, 4. So, same way 1, 8, 1, 8, 1, 8 halogens you can see here. Right? Same way sodium and potassium. If I consider sodium as first element, then 8th element will be potassium. If I consider magnesium as the first element, then calcium will be the 8th element. So that's what we can observe. That's where law of octaves came. So law of octaves, where it talks about similarity in the property with respect to first and 8th element. So what law of octaves talks about? When elements are arranged, in increasing order, of their atomic weights. Here also it is related to atomic weights only. Don't talk about atomic number. Atomic weights, first and eighth elements. First and eighth elements have similar properties. That's what law of octave talks about. Okay. So what is that? When elements are arranged in increasing order of their atomic weights, don't ever mention atomic number. Okay. So increasing order of their atomic weights, first and eighth elements will have similar properties. That's why they are called as law of octaves. Octave stands especially for this reason. Okay. So that's why they are called as law of octaves. All of you have understood? But the problem here is, once again, he was able to arrange only up to calcium. Okay, next elements he was not able to arrange. So that's why we have the Newland's theory, that is law of octaves. All of you have understood? Every eighth element is similar to the first element. That way also you can tell. Or first element will have similar properties to that of the eighth element. That is also fine. Okay? All of you have understood? Any doubts in this? Anyway, I will stop here. Tomorrow we are going to discuss about father of modern periodic table, that is Mendeleev's. Okay, about Mendeleev's classification we have to discuss tomorrow. Then we will go to modern periodic table. But any doubts? So we have discussed today about law of triads and law of octales. We have discussed about two people, two great people. One is Doberiner and another one is Newlands. Doberiner is the one who gave law of triads and Newland is the one who gave law of octales. Okay na? Yes. Thank you. Bye. Take care and solve more problems from your competitive exam boards. Okay? Thank you. Thank you very much. And tomorrow or today you can send me the questions, whatever you are asking. Let me solve those problems. Okay na? Thank you. Thank you. Bye. Take care.